Alright, this lesson we're investigating associations between numerical and categorical variables using a whole range of different methods. So starting with parallel box plots. Parallel box plots are box plots, but they have two or more next to each other. So it's really nice way to compare all the key statistics for different groups. One thing to note about parallel box plots is that the EV actually goes here on this side and the RV goes on this side. So that's different to like histogram, scatter plot, that sort of stuff. So that's, I might put a little star there because that's different to what you're used to. Now obviously, just like a box plot, we have Q1, 2, 3, we've got the range, we've got the outlier, so it's really easy to compare different variables. Sorry, not variables, different groups. They have same variables, this one and this one. So when we compare data from different groups, there are three things that we're looking for. First is to compare the center of the data. So we're comparing medians. Medians are always the safe choice rather than the mean. And then we compare the spread of the data by using IQR or range. But IQR, like we said last time, is a better way of comparing spread. And then lastly, we compare the shape of the data as well. So to do that, starting with the center. Center is the median, and if we have a parallel box plots, it's really easy to see the median. It's given to you with that middle line of the box plot. So you just gotta find the right one, and if you're asked to write about it, you would write always starting with the context of the data, like what this is about, and then you want to obviously give the actual data in your writing as well for the groups that we're comparing. Same goes for comparing the spread. So you start with the context again, and then use IQR and to find the IQR from the box plot is also pretty straightforward. You've got your Q3s here for each of the groups, Q1s here, so you just need to do minus Q3 minus Q1 to get your IQR. And comparing shape as well, box plots give you a shape. Example, this, in a box plot, the first line here, anything below that is your first 25% of the data. This is your next 25% of the data. This is the next 25. So 25 here, 25 here, 25 here, 25 here. So if they're all sort of evenly spaced out like this one, you would imagine your data is sort of nice and symmetric. Whereas this one here, it's all nicely spaced out. Then you have a big range sort of in your last 25%. So this data will look somewhat like sort of goes up nicely, and then at the end, that's pretty hard. Goes up nicely, and at the end it's sort of like more trailing to one side, so it has a bit of skewness there. Similar with this one, but this one's even more so. There's a lot here. That's 50% of the data all squished at the start, and then 25 here, 25 here has sort of a larger range, so it sort of goes like a bit down like that. So this also skewed, and this one is even more extremely skewed. Like first 50% of the data is like all at the start. It's more like this, and then it goes really stretched out towards the end, so you can see that's also skewed. So just by looking at the box plot, you know the shape of the data as well. So you just gotta mention those for the ones that you're comparing. And all of this can be done not only using parallel box plots, but we can use parallel dot plots. So really the same process, but dot plots are not as efficient because it doesn't give us the median or Q3 or Q1. We do have to find it out ourselves. Best thing to do is that using this method of n+1 divided by 2 to find the location of the median and sort of count and see where your median is. And then after all of that, you can come to a conclusion using the actual values of the median. And lastly, so the same idea here, but now you can use back-to-back stem and leaf plots. It's really only good if we have some small data sets, because you'll have to write all the data sets one by one. So if you have a big data set, it's really hard to construct one. So back-to-back stem and leaf plots, they share the same stem, and we have one variable on this side and the other one on this side. Obviously you have to have the key as well, and also with this one you have to find the median using the median method as well. So not as useful, but it is doable. It is doable to find the median like so and come to a conclusion as well.